Good evening, students. Welcome back to Mahadeva International School. We shall discuss about the physics chapter, kinetic theory of matter, which we were discussing in the previous class. So, in today's class, we shall study about the molecular arrangements in gases. So, in the last class, we had studied about molecular arrangements in solids and liquids. So in today's class, we shall discuss about molecular arrangement in gases, that is how the molecules are arranged inside the gas. Gases have large intermolecular distance and negligible intermolecular force of attraction. This makes gases highly compressible. As you can see here, these are the gas molecules. You can see a large space between these molecules. That is intermolecular distance. That is, the gases have large intermolecular distance. The distance between these two molecules is very high. And second is they have negligible intermolecular force. That is, there is no force between these two molecules. That is why as much as possible you can compress the gas. The Brownian motion of gas molecules is faster than that of liquid. That is why the fragrance of a scent spreads faster in whole room. That is, the gas molecules move faster than the liquid. That is the reason why if someone has been sprayed with a scent or a perfume or incense stick, the smell spreads in a complete room. Why? Because the molecules move faster than the liquid. Gases have neither a fixed shape nor a fixed volume. So, these gas molecules will never have a fixed shape or they will never have a fixed volume. That is, they takes the shape of a container. Like for example, if I have a gas cylinder, these molecules take the shape of a cylinder. Heating makes their molecules movement more violent and they have the capacity to expand the most. So whenever I am starting heating these molecules, that is the molecules in the gas, they gain more energy and they become more violent. That is, they move with a high speed. Next is the last topic of this chapter we shall study is the surface tension. The property of a liquid by virtue of which its surface behaves as if it is covered by a membrane or skin which is under tension is known as surface tension. That is, it is a property of a liquid, okay, by virtue of which the surface behaves as it has been covered by a membrane. So the total surface behaves like something has covering it. So such type of membrane is called as surface tension. A liquid taken in a container has a property that its free surface behaves like a stretched membrane with a tendency to contract and acquire the minimum surface area. This property of liquid is called as surface tension. So as you can see here, so you have a container and there is some liquid filled with it, and each and every molecule exerts a pressure on other molecules. Okay. Now, what makes this surface tension cause, or how the surface tension is caused? Every molecule in the middle of a liquid is being pulled by other neighboring molecule. For example, a molecule A inside the liquid experiences a equal internal molecular force of attraction from all the sides, and hence the net force on it is zero. So let us take two molecules here, molecule A and molecule B. So molecule A and molecule B applies each force on each other. That is, A is exerting force on B or B is exerting force on A. The total net force on these both will be zero. For a molecule on the surface of the liquid like B, the intermolecular force act in the downwards direction as there are no molecules of the liquid in the air. So you can see here This is in the middle. That is why this is applying force on all the directions. Whereas when we are talking about the molecules near the B, so what happens here is it is not exerting more pressure. It is exerting the pressure only in the downward direction, not in the upward direction. Okay, it is due to the surface tension. So hence a net downward force acts on the molecule on the surface. As a result, the liquid surface is always under the tension which is on the surface. So the molecules which is on the surface here on the top of this, they will have the surface tension. The force of surface tension tends to reduce the surface area of a liquid to a minimum. Since out of all the shapes, the sphere has the minimum surface area for a given volume, liquids have a tendency to form spherical droplets. Okay, so in detail, we shall study this in your next classes, that is in the higher classes. So just as of now, you can know what exactly the surface tension is. So this is the last topic of this chapter. So please wait for the notes. You will get the notes and you have to get prepared. So from the next class we shall start with chemistry or biology and we will take a new chapter. So until that, please go through all the videos which has been uploaded on this chapter, revise it once again, and after every chapter we shall have a test. So get prepared for the test. Okay, so today this is the topic for today. So we shall continue in the next class. So have a good day, good night, take care.